So whereas we're pretty confident about 5 plus 3 is 8, 8 plus something unknown may not really still be 8, which means that first decimal place is no longer reliable. Adding the 8 to something unknown makes this unreliable. We need to round it to be showing reliance at the ones place value. We're in between 8 and 9. Is it going to round up to 9 or down to 8?
Up to 9.
Up to 9. Proper answer here is 9. You can trust both of those numbers at the ones place value. You cannot trust them both at the tenths. Therefore, you can't report an answer to the tenths. So you round that up to be an answer of 9. Now the next one, this one has 2 place value. This only has 1. So we can't keep what's out there. We can keep to the first decimal, but not anything farther than that. What's this going to round to be?
9.4.
9.4. Properly phrased, this is 9.4 as your answer. Two decimals, 1 decimal. We can't keep 2 decimals. What's this round to be? 10.4. Next one. We're going to have to lop this one off at the ones, correct? Because we don't know any decimals on that 4. So what's the answer? 10 is almost right. Why do you need the decimal? Because if you don't have that decimal, it looks like that 0 is placeholder. Remember the 14,000 and 14,000 decimal a while ago? This is that case. If you just write 10, it looks like this is reliable, but this is not. But that's a placeholder. That's not what you mean. The ones place is reliable, so we indicate that by putting the decimal in. So 10 with the decimal showing indicates that that's 2 significant figures and reliable to the ones place value. Question with that?
So we'd have to do it on the one before, the 5.8 plus 3.4.
If you want to put the decimal there, you can. It's really only necessary with a 0, because remember, digits 1 through 9, if you see them, you trust them.
Okay.
Right? It's only the zeros that are suspect. So it's perfectly fine to put the 9 and dot, but it's not necessary. It is necessary here. Properly phrased, what's the next one? 0.21. Because we have to cut it off here, that's going to round up. 0.21 would be the answer. Yes?
And the last one, how could you put the 10, because you don't know that it could be 10? You don't know that for sure.
Well, we know this at the ones place value and this at the ones place value. So that means we can trust the total to the ones place value. Both of these numbers are known at the ones place. They're not both known at the decimals. So the last place, and you still expect a little bit of variance in that last reported one. And that's why you stop there. But anything beyond that 0 would be completely unreliable. Next one. These are significant. These are significant. We'd have to cut it off here. It's not very linear, but that's where we'd have to cut it. And that would round down to 17,900.
Do you put your decimal there?
If you put a decimal there, you're saying the ones place is trustworthy, and it's not. So no, you do not have that. These are significant, but these zeros are not. This is one of those that would actually be nice if you put it in scientific notation, because in scientific notation, you don't even see those placeholders. If the number's in scientific notation, then everything you see is significant. But that's, I'm gonna rest that back off, because that's not really necessary. What's necessary is rounding it at that point. You cannot keep beyond the hundreds place value. Next one.
17/12.
Because of the decimal, these zeros count. You can trust everything to the ones place. That one's fine the way it is. You can keep all of that. You can legitimately keep all of that to the ones place. Question. All right, last two, these are subtraction. This one would have to be cut at the ones place. We can't keep the decimal because the 92 doesn't have any decimals. You're between 8 and 9, closer to 9. Proper answer is 9. The last one, likewise, we can't keep the decimal. Between 9 and 10, going round to 10, which is the nearer number, and because you want to show that the ones place is trustworthy. Never trust a calculator for significant figures. Calculators are notoriously bad at significant figures because they're just going to add up the numbers with no regard to what's approximate and what's exact. They can't tell the difference. So this kind of thing is something you're always going to have to think about when you get to the end of a calculation, is how to go back and properly phrase that numerical answer. Question. The multiply divide rule we'll do next time. We'll start with that multiply divide rule and work on from there. In the meantime, go back over what we've already done. Go over the parts we've skipped, fill those in. Make sure you have access to D2L, and if you cannot get in for any reason, let me know. And make sure you have your lab book and appropriate attire when you go to lab this week.
We have a lot every week.
Lab,
We have a lot every week, or just every other week or so.
it's every week, not